Welcome to AQA Chemistry for the 2015 specification 1.2 mass number, atomic number and isotopes. If you need to look at your textbook to help with this, and you've got the Oxford University Press book, then it's pages 6 to 7. So our lesson objectives for today are to define atoms and ions in terms of the numbers of protons, neutrons and electrons, as well as atomic number and mass number, and also to explain the existence of isotopes. So if we look at lithium here, if you look in the periodic table for lithium, you'll notice there are two numbers by it. One which is 7 and one which is 3. So the larger of the two numbers, which for lithium's case is 7, is called the mass number. And that tells you the number of protons and the number of neutrons added together. So in this case, for lithium, there are 7 nucleons. The atomic number Z tells you the number of protons. So in this case for lithium it's 3. So there are 3 protons in a lithium atom. So if you look at any element in the periodic table you will see the two numbers. The larger of the two numbers is the mass number A, and the smaller of the two numbers is atomic number Z. The only exception to this is for hydrogen, where both numbers equal to 1. Now we said the atomic number Z equals the number of protons. It also equals the number of electrons in an atom, not in an ion but in an atom, because an atom is electrically neutral and a proton has got a +1 charge and an electron has got a -1 charge. If you have a neutral atom, then the number of protons has also got to equal the number of electrons. So in a neutral atom, the atomic number Z is also equal to the number of electrons. And the important point about this is that all atoms of an element have the same atomic number. So they have the same number of protons and the same number of electrons. And because they have the same number of electrons, they have the same identical electron configuration and therefore the same chemical properties, which is why all atoms of an element behave chemically the same. So what you need to be able to do is to calculate the number of fundamental particles in an atom or an ion. So for a neutral atom, the number of protons you can easily work out because it equals the atomic number. And the number of electrons, as I said on the previous slide, has to be the same in an electronically neutral atom. So the number of electrons is also going to be equal to the atomic number. Now the number of neutrons you can quickly calculate because it's going to be the mass number minus the atomic number. So if you think back to the previous slide, we said the mass number equals the number of protons and the number of neutrons added together. So we already know the number of protons is the atomic number. So if we take that away from the mass number, that tells us the number of neutrons. So if we have a negative ion, then it's going to be as above for the neutral ion, except that because it's a negatively charged ion, you've got one or more additional electrons. So to work out the number of protons and neutrons is exactly the same as the neutral atom. To work out the number of electrons, that's going to be equal to the proton number added to the charge on the ion. Because for each -1 charge on the ion, you're going to have added 1 extra electron. For a positive ion, it's going to be as above for the neutral atom, except that because it's a positive ion, it's lost 1 or more electrons. So the number of protons will be the same, the number of neutrons will be the same as the neutral atom, the number of electrons will be equal to the proton number minus the charge on the atom, because you've lost electrons. So here's some examples for you. So if you took lithium, as we said, it was 7 and 3. So the mass number was 7, the atomic number was 3. So based on the rules that we've just said, the atomic number is 3, so you'd have 3 protons. It's electrically neutral, so you'd also have 3 electrons. And the difference between the mass number and the atomic number is 4, so we have 4 neutrons. So for a lithium plus ion, the number of protons and neutrons is exactly the same, but we've got 1 less electron because we've got a +1 charge. So the number of electrons then is 2. For the oxygen, so if you look at the oxygen, you've got a mass number of 16 and you've got an atomic number of 8. So the number of protons is equal to the atomic number, that's 8. It's electrically neutral, so that's also the number of electrons is 8. And in this case, it's very symmetrical because 16 minus 8 is 8, so we've also got 8 neutrons. Now oxygen forms an O2 minus ion. So as we said, the number of protons and neutrons stays the same. So again, we've got 8 of each of those. But now we've got a 2 minus charge. We've added 2 extra electrons. The number of electrons is now the number of protons, which is 8, plus the charge on the ion, which is 2. So 8 plus 2 gives us 10. So the next thing you need to know about is isotopes. So isotopes you'll have met at GCSE. They are atoms with the same number of protons, but different number of neutrons. So this means the atomic number is the same, but the mass number is different. Now, because the number of protons are identical, the isotopes will also have identical numbers of electrons, which means they've got the same electronic configuration, which means they've got the same chemical properties. And this is quite a common exam question that isn't particularly answered well, so make sure you understand that the isotopes will have identical chemical properties because they've got the same number of electrons, they've got the same electron configuration. Back to our lesson objectives, which were to define atoms and ions in terms of number of protons, neutrons and electrons, as well as atomic number and mass number, and explain the existence of isotopes. So as usual, if you don't understand these, go back and look at your textbook, go back and watch the video, do whatever you have to do to make sure you can understand it before you start the lesson. If you're watching the Office Mix version of this video, then there will be some quizzes on the next slide to check that you can understand the material.